Hello everyone, welcome to the next video of data structure and algorithm. In this video, we'll learn how to delete the last node in double linked list. Okay? So in the representation, we have seen that every node is capable of keeping the address of the next node as well as address of the previous node and the information associated with it. Okay. Now, if I want to delete the last node, I am having only information is start. So how to operate from start so that I can delete the last node. Okay. So if I want to delete the last node, I have to reach here so that this next part I can keep null. This is the only change I have to make. Then I can delete this one or I can free this one. Okay. So I have to reach here as well as I have to reach here also so that I can use free to delete the location 4000. Okay. So we are having the only information start. So what we will do, we will give the value of start to temp. Okay. Now temp will reach to the last node. How? Now I have to search that particular node whose next is null. So that means I'll just put a condition that while temp next is not equal to null, still I am not getting the node whose next is null, temp will go to the next node. Okay. So by doing this, temp can reach at the end. There is no problem. But I need the address of this node also. Unless and until I'll get the address 3000, how I can make the next as null? So before temp will go to the next node, it will give its address to PTR. One more pointer. So that means when temp will come to the second node, PTR will point to the first node. When temp will come to the third node, PTR will point to the second node. When temp will point to the last node, PTR will point last but one. Okay. So after this loop, a simple statement I'll write PTR next equal to null. So what will happen? This connection will be deleted. And after that, simply I'll write free temp. So what will happen? Now the entire memory block will be deleted from the list. Okay. So the best thing is here that whatever the concept or logic we have applied for single linked list, the same thing we will apply for double linked list. Okay. So we have copied the entire program of delete end of single linked list and we will do the modifications if required. So why I'm telling if required, we will know right now. So first we are checking whether list is empty or list is non-empty. Okay. So that will be known from the value of start. So if start equal to null, list is empty, nothing to do. Otherwise, you give the value of start to temp. Then we are checking whether a single node is present in the list or not. How I will know that? To whom start is pointing, if its next part is null. That means a single node is present that is pointed by start, and we are checking that next part of that particular node is null. So that means a single node is present. So start info we are deleting, just putting a message, free temp and start equal to null. If more than one node is present, then first of all I need to reach at the end. So temp will start from the first node because start has been given to temp. Now we are putting the loop temp next is not equal to null because the speciality of the last node is its next is null. So till that particular node is not reached, temp will go to the next node. But before temp will go to the next node, it will give its address to PTR. Okay, so currently, if you'll understand, PTR will follow temp. So temp will go one node ahead, PTR will just follow that particular node temp. Okay, so finally this loop will be over when temp will point to the last node. Then, then we are printing temp info is the node what actually you are deleting. And last but one that is pointed by PTR next equal to null. So now the connection is disconnected. Okay, so that means now PTR is the last node and its next part is null and then free temp. Okay, so the best thing is whatever the code you have written in single linked list, no need to modify because the entire code will be same for double linked list. Okay, because we will follow temp will point to the last node, and finally ptr who is pointing to one node before, so that will be next part will become null. Okay, so for menu driven program, option 7 we have given delete end. Now here option 7 delete from end. Okay, so let us check. Open. Now the option is coming. So first of all, it traverse. Now list is empty, nothing is there. Clear? So 6 number of nodes I am creating. Now list is created. Let us traverse. So these are the nodes which are present in the list. Suppose I want to delete from end, option 7. Now you can check 66. The deleted node is 66. How will know that? Once you will traverse, 66 is not there. Clear? Once again, I am giving the option for delete from end. Now you can check 55 has been deleted. If you will traverse, you can check 55 is not there. Okay. So the program is very simple and completely similar to the program of delete end of single linked list. Okay. Only you need to understand the concept, how you are implementing. Clear? Now the same thing we have incorporated in the algorithm. So first you are checking whether the list is empty or non-empty. If non-empty, then temp will reach to the last node after this loop, and PTR will point to one node before the last node. So then PTR next will become null, so that the connection between last and last node one will be disconnected. Okay, then you are just using free to delete that particular memory location of the last node. Okay, so the program and the concept is completely similar to single linked list. First, you have to understand the code of single linked list. Then you have to relate with the code of double linked list, so that you can find there is no difference between single linked list and double linked list with respect to delete from end. Okay. So thank you everyone for watching.